Okay, so this is question number 22 from this worksheet. It says the point A has coordinates 1, 5, and the line L has gradient minus 2 over 3, and this line L passes through the point A. A circle has center 511 and radius square root of 52. Show that L is the tangent to the circle at A. Okay, so how do we think about this? What information are we given? We're given that the point A has these coordinates and the line L has this gradient. So there's point A somewhere, there's point L somewhere, and the line L passes through the point A. And there's a circle with center 511 and radius square root of 52. Now, in questions that involve circles in particular, and in general, all coordinate geometry questions, if you do not have a diagram given, it's often helpful to draw a rough sketch to try to understand the situation better. So in this case, if you were to draw a circle, this is what it might look like. And we could say this is the center of the circle here. Let's say this is the center of the circle. And the center of the circle has coordinates 511. Let's name the center something. Let's call this center C, and the center has coordinates 5 and 11. The radius of the circle is square root of 52. That's what we're given. And this point A, 1, 5, that they are saying eventually lies on the circle. You have to prove that, but since you know that it's going to lie on the circle, you can represent that in a way that it lies on the circle. Now, which direction is point A going to be in? You can see the center is 511, and the point A has coordinates 1, 5. So with respect to C, in which direction should A be? A has coordinates 1 and 5. That means the x coordinate of A is less than 5, so it should be on the left. Y coordinate is also less than 11, so it should be below the center. So we could mark the point A somewhere on this side. So it will be on this side somewhere. Okay, let's say this is the point A. This point A has coordinates 1 and 5. Now there's this line L that passes through A and has gradient negative 2 over 3. The line looks like this. The line looks something like this. Okay, this is what the situation looks like. This is the line L that they're talking about. And this line L has gradient negative 2 over 3. We need to show that L is the tangent to the circle at the point A. Now, how do we show that L is a tangent? Now, this is very important. There are two conditions that you need to make sure that the point A and the line L is basically meeting. And they are, if you were to draw a line from the center of the circle to the point A, this would be the radius of the circle. Since tangent is supposed to be perpendicular to radius, if line L is supposed to be the tangent, this angle has to be 90 degrees. So we need to prove that the radius of the circle and this line L, they are perpendicular to each other. That is one thing that we need to prove. Okay, one thing that we need to prove is that the radius of the circle at the point A, which is AC, that is perpendicular to the line L, because radius and tangents are supposed to be perpendicular to each other. So in order to prove that line L is the tangent to the circle at A, that's one thing that you need to do. So let's find the gradient of the line AC, which is the radius. Gradient of AC. Okay, what does that turn out to be? 11 minus 5 divided by 5 minus 1, and this gives us 6 over 4, which is 3 over 2. what's the gradient of the line L? They've given us the gradient of the line L already, and that is minus 2 over 3. And you can see these are negative reciprocals of each other. That means AC is perpendicular to the line L. So that is confirmed now that they are perpendicular. Okay, line L and AC, they are perpendicular to each other. However, this is not enough to prove that line L is a tangent, because it could be possible that A was here and it did not lie on the circumference. And if you were to draw this line AC, it might have looked like this, and the line L might have looked like this, and still AC and the line L, they would be perpendicular to each other. So just proving that AC and line L are perpendicular to each other is not enough. It's not enough to prove that it's a tangent. Okay, it's not enough to prove that this is a tangent. So what do we do instead then? There's one additional thing that we need to do, and that is we also need to prove that the point A lies on the circumference. They have not given us this information. For the line L to be a tangent to the circle at the point A, the point A has to lie on the circle first. If it doesn't lie on the circle, then it can't be a tangent, right? Nowhere in the question do they tell us that the point A lies on the circumference of the circle. So we also need to prove that the point A lies on the circumference. In fact, that should have been the first thing that we proved, that the point A lies on the circumference in the first place, because otherwise you can't have a tangent at the point A. So how do you prove that now? How do you prove that the point A lies on the circumference? Now, if you had the equation of the circle given, you could just put that point there. That could be one possibility. If that point satisfies the equation of the circle, then you would say that the point lies on the circumference. Okay. Or you could just find the distance AC. If the distance AC is the same as the radius, that means that the point lies on the circumference. There are two possibilities. You either find the equation of the circle, put this point A in that equation. If it satisfies the equation, that means it lies on the circle, lies on the circumference. The other possibility is you find the distance between the points A and C. If that also turns out to be square root of 52, that means AC is supposed to be the radius and A lies on the circumference. So you could do either of those two things. Now, let's write down the equation of the circle. That's probably easier to think of. Write down the equation of the circle. You have the center, you've got the radius. You can write down the equation in one single step. You can say that's x minus 5 whole squared plus y minus 11 whole squared. That is equal to square root of 52 whole squared, and that gives us 52 on the other side. That's the equation of the circle. Now what you do is you put the point A here. Point A is 5, 11. Okay, let's put that here. 5 minus 5. Okay, no, sorry. A point A is not this. The point A is 1, 5. Point A is 1 and 5. Let's put point A here. That gives us 1 minus 5 whole squared plus 5 minus 11 whole squared equals 52. And that gives us 16 plus 36, which is 52. So we have 52 equals 52. That means A lies on the circumference. That's the first thing you have to prove, that A lies on the circumference. That's one thing proved. Now, since A lies on the circumference, and we also proved that AC and L are perpendicular to each other, this would be the second thing that you prove now. You would say gradient of AC then is 3 over 2. Gradient of L is minus 2 over 3. These are negative reciprocals of each other. And that proves the second thing, which is AC is perpendicular to L. And AC is the radius now. We know that for sure because A lies on the circumference. We have already proved that. Both of these things together, this thing and this thing, both of these things together, they mean that line L is a tangent to the circle. At the point A. So in order to prove that a line is a tangent to the circle, you need to do two things. Number one, you need to prove that it touches the circle, just like this. In this case, we proved that A lies on the circumference. And the second thing, that the radius is perpendicular to the tangent. Both of these things have to be shown, and that together proves that the line is a tangent to the circle. Is this point clear to everyone? Make sense?
Yes, sir.
Okay. Let's look at the second part now, part B. Now, part B says, find the equation of the other circle of radius square root of 52 for which line L is also the tangent at A. So now we've got another circle that has the same radius, and the line L is also the tangent at the same point A. Now, how do you understand this? Let me just copy this here. This is the diagram that we get. We've got this point A and the point C. Now there's another circle that has the same radius. The radius of that other circle is also square root of 52. So it's the same size as the first circle. And the line L is also a tangent to the circle at the same point A. Now, where is that other circle going to be? We need to write down the equation of that circle. Okay. Now, how can we do that? Let's make another circle of same size. So this is another circle of exactly the same size. This has to be the tangent to the circle as well, to the first circle. Tangent to that line L as well at the same point A. So this is roughly what it's going to look like. Okay. Now, how do you write down the equation of the second circle? How can we write down the equation of the circle now? For writing down the equation of a circle, we need two things. Center, the coordinates of the center, and the radius. Now, we know the radius of the circle is also square root of 52. So wherever the center is, let's say this is the center of the circle. Let's call the center something else. We already called this C. So we can say this is O.
Sir,
this radius is, yes.
Sir, will coordinates of the center be also the same for the other circle?
How can the coordinates of the center be the same? It's as in this is
Yes,
if this is
yes,
5
okay.
if
Okay,
this is
okay.
511, if this is 511, you can't have another point
Okay.
that's also 511, right?
Yes, yes.
Okay, so point O, radius is the same. How do we find this point O? That's what the question is now. Because once we have the center of the circle, we can write down the equation after that. What's the standard form? X minus a whole squared plus y minus b whole squared equals r squared. And now the problem is, how do you find the center of this other circle? Any idea? What do we do? How do we find the center of this other circle? Anyone?
It would be the same distance as from the tangent. So we could we could I forgot the name. We could use vector law to find it.
Yeah. So we could use either the idea that A is going to be the midpoint of both both the centers, right? So you could use the midpoint formula with A being the midpoint of O and C, and use that to find the point O. Or a quicker way of doing this is the vector method that we did in coordinate geometry earlier. Use the vector method like this, that you have a line like this from O to C. A is in the middle. A is somewhere here. We know the point C. We know the coordinates of the point C. The coordinates of the point C are 5, 11. and the coordinates of the point A are 1 and 5. And what we need to do is we need to find the coordinates of the point O. How can we find them? Using vector method, we could just write it like this. We could say the coordinates of C are 5, 11, and A are 1 and 5. What about O? How many units do you have to go on the x-axis to go from 5 to 1? -4. So you go -4 more to get to the x coordinate of O, which is going to be -3. 1 minus 4, that's -3. Okay. And then similarly, you do the same thing with the y coordinate. How do you go from 11 to 5? You have to subtract 6. So that's -6. You do -6 more. 5 minus 6, that gives you -1. These are going to be the coordinates of the second circle, the center of the second circle. Okay. -3 and -1. So this point, therefore, is -3 and -1. That's the center of the other circle. And now we can write down the equation. The center is -3, -1. And the radius is the same as before. That was square root of 52. So how do you write down this, the equation of the circle then? X minus a whole squared. That means x minus -3. That becomes x plus 3. X plus 3 whole squared plus y minus b whole squared. Y minus -1. That becomes y plus 1 whole squared equals square root of 52 whole squared, which gives us 52. That is the equation of the other circle that we were looking for. And that's your final result. Okay. So that's how we find the equation of this other circle, which is on the other side of this line, and line L is the tangent to the circle. Now, there's another way of doing this. There's another similar question that comes, and that will look like this. You might have seen something similar in some other past paper or also in the worksheet, that they would say that this line is the line of reflection of these two circles. That also happens sometimes, that they would say the line L is the line of reflection of these two circles. If the line L was a line of reflection, in that case as well, the circles would have the same radius, right? They would have the same radius. And A would still be the midpoint of A and C, of O and C, sorry. And you could use exactly the same method for finding the equation of the other circle in that case as well. All right, so that also happens sometimes, that they say that some line is a line of reflection of two circles. In that case, in order to find the equation of the other circle, you use exactly the same idea. Make sense? Any questions on this, anyone? Any problems? No? Okay, let's move on to the next question then. So the next one that you're saying is question number 18, and then we do that one that you're saying, Abdullah, from a past paper. Have a look at that as well. Let's start with this one first. Question number 18 now. Okay, question number 18 from the worksheet. Let's try this. Okay, so now we have a circle that has center at the point B, and there's a point A that lies on the circle. Lying on the circle means it lies on the circumference of the circle, right? We need to find an equation, find the equation of the circle, and that's pretty straightforward. B is the center, A is the point that lies on the circle, lies on the circumference. All we need to write down the equation of a circle is center and the radius. Now it's going to look something like this. Or in fact, there's no need to draw at this point. You can do it directly. B is the center. A is a point on the circumference. How do you find radius? You can just find the distance between these two things. Between these 2 points, you would say radius equals AB, the length AB. That's x2 minus x1 whole squared plus y2 minus y1 whole squared. And square root of that. So x2 minus x1, you could say that's -1 minus 5 whole squared plus -2 minus 1 whole squared. And that's going to give you 36 plus 9, that's 45, square root of 45. That's the radius. Okay, so you've got the radius of the circle. And then you write down the equation of the circle. X minus a whole squared plus y minus b whole squared equals r squared. Just input values in the circle, in this equation, and you get x minus 5 whole squared plus y minus 1 whole squared equals r squared square root of 45 whole squared. That gives you 45, and that's the equation of the circle that we were looking for. Okay, so that's the first part, quite straightforward. That's 3 marks for some reason, but this is all that you had to do for that. Okay. All right, let's look at part B now. Part B says point C is such that AC is a diameter of the circle. Point D has coordinates 5, 16. So there's another point C now, such that AC is the diameter. Point D has these coordinates 5 and 16. Show that DC is a tangent to the circle. So again, it's the same idea. You need to prove that some line is a tangent to the circle. Remember those two things that we proved in the last question as well. You have to prove that one of D and C lies on the circumference, or some other point on this line lies on the circumference of the circle, and also that the radius is perpendicular to the line DC. You have to do two things, okay? Now, it's going to be helpful if you draw a rough sketch of this to understand the situation better. So let's do that. Let's draw a rough diagram to represent this, and that will help you with some thinking. Let's say this is what the circle looks like. Now, the center is going to be somewhere here. We know the coordinates of the center. We know that the center is B, and the coordinates of the center are 5 and 1. So B is 5, 1. Okay, now let's mark the other 2 points as well. We have a point A, and we have a point C, right? This is the other point. A lies on the circle. We know the coordinates of A. Now, when you are marking this point, you should always think about where exactly on the circumference you should mark it. -1 and -2. So think about the center of the circle and this point. With reference to the center of the circle, in which direction is the point A going to be? You see, the x coordinate of the center of the circle is 5. X coordinate here is -1. That means it should be to the left of the circle, right? Because the x coordinate of A is less. Y coordinate of B is 1. Y coordinate of A is -2. So y coordinate of A is also less. So it should be to the left of the center and below the center. So we could mark that point A somewhere in this direction. We could say this is the point A, let's say. Point A has coordinates -1, -2. So point A is going to be in this direction. Okay, so this is important to mark the point in the correct direction. Okay, it's not necessary that you mark it exactly in a very accurately, but the rough direction should be accurate. As in, is it to the left? Is it to the bottom left, bottom right, top left, top right? At least that should be reasonably accurate. And now it says point C is such that AC is the diameter of the circle. Now, AC is diameter. We know the coordinates of the point A, and the point A lies here. Where is C going to be? If AC is the diameter, C is going to be on the other side of the circle. It's going to be on the other side of the circle like this. This is going to be the point C. Now, since AC is a diameter, we know for sure that C lies on the circumference. So in this case, we do not need to prove that C lies on the circumference. So we just have this point C. We have shown, we know that C lies on the circumference, okay? And now there's another point D that has coordinates 5, 16. Where is this point going to be? 5, 16. Think about it. X coordinate is 5, Y coordinate is 16. You see the center also had X coordinate of 5. This also has X coordinate of 5. So the point D is basically going to be right above this point and on the same vertical line. So maybe, so let's actually think about The radius of the circle, what was the radius? Square root of 45. Square root of 45 is 6 point something. So it's 6 units up to this point almost. So that's 8. So it's way above basically. So maybe somewhere here, let's say. This is the point D somewhere. 516. It's exactly above the point B, exactly above the center. Why? Because the x coordinate of the center and the point D, they are both the same. Okay, so it's going to be exactly above this point like this. Now it's actually not going to be very accurate if we do it like this. We bring it down a little, so it looks like a tangent. Then we draw a line from there. Yeah, okay. So let's say this is what the tangent looks like. It's again not very accurate yet. It has to be perpendicular. We bring it a bit down again. Now, of course, it's a rough sketch. It's just for your own understanding. But if you draw it good enough, it will help you with the calculation. Try to understand the situation better. This is the point D. Okay, this is what the situation looks like. Now, how do we prove that DC is a tangent to the circle? All you have to do is find the gradient of the line BC and the gradient of the line CD and prove that they are perpendicular to each other. But the problem is we do not have the point C. We do not know the coordinates of the point C, right? However, since we know that AC is diameter of the circle, B is supposed to be the midpoint of AC. So if we can find the point C somehow, using the same method that we used in the previous case, B is the midpoint. You can use the vector method. You can say A is -1, -2, and B is 5 and 1, and C is what you have to find out. How do you go from -1 to 5? You have to add 6. How do you go from -2 to 1? You have to add 3. You add 6 more to get 11 as the x coordinate. You add 3 more to get 4 as the y coordinate. So the point C has these coordinates, 11 and 4. And now all you have to do is find the gradient of CD. Gradient of CD. And find the gradient of BC. And see what they turn out to be. They should be negative reciprocals of each other. Let's figure that out. BC and CD. Okay, CD has gradient 16 minus 4 divided by 5 minus 11. That will be 12 over -6, which is -2. Gradient of BC, that's 4 minus 1 divided by 11 minus 5. And that turns out to be 3 over 6, which is 1 over 2. So this gradient is 1 over 2. Now again, you can see they are negative reciprocals of each other. And that means CD is perpendicular. CD is perpendicular to BC. Therefore, since we already know that C lies on the circumference, CD is a tangent. Right? Because BC was the radius. It's perpendicular to the radius, and the point C lies on the circumference. Both of those things together, they mean that CD is the tangent. Okay. All right. Now, what's the next part? Now it says the other tangent from D to the circle touches the circle at E. Okay. So now we have another tangent coming from that point D, and it touches the circle at E. Now, where is that other tangent going to come? It's going to come on the other side, right? So it will be somewhere around here. We could draw a line like this. This is another tangent. And this point here, where this tangent is being made, this is point E. We need to find the coordinates of the point E. Okay, how do you find the coordinates of this point E now? Let's think about this. So you see, this is what the situation looks like. Remember, the point D is directly above the center of the circle like this. The point D is directly above the center of the circle. Now, since it's directly above the center of the circle, it has the same x coordinate. Now, remember the property of circles. You have two tangents coming from outside the circle. Remember what the shape is going to be? The shape is going to be a kite, right? We've done this in circle properties. The shape is a kite. And what do we know about kite? The diagonals of kites, they are perpendicular to each other. And one of the diagonals also meets at the midpoint. So this point here, let's call this M. M is the midpoint of E and C. M is the midpoint of E and C. Okay. Now, since M is the midpoint of E and C, what we can do is we can use that to figure out the coordinates of the point E. Okay, we can use that to find the coordinates of the point E. How can we do that? Well, think about it. If M is the midpoint, do we know the x coordinate of M already? We do, because this point has x coordinate of 5. This point has x coordinate of 5. So the x coordinate of M is also going to be the same. It's going to be 5 something, right? We don't know. What about the y coordinate, by the way? This is a horizontal line, right? Because since BD is vertical and EC is perpendicular to that, EC is supposed to be horizontal. Now, if EC is horizontal, what that means is the y coordinates of all points on this horizontal line, they are going to be the same. So this y coordinate is also 4, and the y coordinate of E is also going to be 4 because of that, because it's a horizontal line. EC is a horizontal line. Why? Because BD is vertical, EC is perpendicular to that, so that's horizontal. So the y coordinate of E is going to be 4. How do you find the x coordinate? Well, you know that this is 11, this is 5. M is the midpoint of E and C. Can you find the x coordinate of E using that information? Since it's 6 units from M to C, it should be 6 units from E to M as well. This should also be 6 units, right? So 5 minus 6, what does that give you? That gives you -1. So you can actually just figure these coordinates out like this and write down the answer directly from the diagram. You could say the coordinates of E are -1 and 4, and that is what you were looking for. You only would have marks for 1 mark for the x coordinate here, 1 mark for the y coordinate here, no marks for working as such. It's only a 2-mark question. They only want you to write down the coordinates. You can do it anyway, but this is how you can do it quickly by just looking at the diagram. If you've drawn a good diagram, that will help you understand the situation better. M is the midpoint. So we use the midpoint to find the x coordinate of E. The y coordinate is the same as the y coordinate of C. And that will give you the coordinates of the point E. Does that make sense?
Yes, sir.
Okay. Any other questions from the worksheet? Are we done with all the questions from the worksheet then? No problems from that?
Sir,
Yes.
sir, can we also use midpoint formula?
Yes, you can use the midpoint
Yeah.
formula as well. That's going to take slightly longer, but you can do that. Okay. All right, good. So if there are no other questions from the worksheet, there's another question from a recent paper that Abdullah is asking about. Should we just do that now? No other questions from the worksheet? Tomorrow, we will be doing AP, GP questions from the worksheet and otherwise then. Okay, so that will be the last thing that we're left with. Okay, so I think there are no other questions then. Let's just do this one last problem from this recent paper. Abdullah, we were going to do that anyway in that session today, no? November 23, paper 1-1. Yeah, okay, so that's the one that I assigned
Okay,
to you,
sir.
right? Okay, but let's do it right now since you asked right now. So those of you not in the session, I'll just explain it for you as well. Where is that? Past papers. Okay, this is the paper, right? Paper 1-1. Okay, let's try this. This is question number 11 from this paper, November 23, paper 1, variant 1. Let's try this one. All right, let's do this last question for today then on circle equations. So the diagram shows the circle with equation x minus 4 whole squared plus 5 plus 1 whole squared equals 40. Parallel tangents. Okay, so these are parallel tangents. That means they have the same gradient. Each with gradient 1, so we know their gradients as well. Touch the circle at points A and B. Find the equation of the line AB, giving the answer in the form y equals mx plus c. Okay, so we need to find the equation of the line AB. That is this line. Okay, both of them have gradients of 1. Now, how do you find the equation of this line AB? Now, remember, it's a straight line. Straight lines, for writing down equations of straight lines, we need two things. We need the gradient of the line and any one point that lies on the line. Okay. Now, we don't have, we have the gradient. In fact, we have the gradient given. Gradient is supposed to be 1. We know that. For the line, for the tangent, for the tangents, the gradient is 1. If the tangents have a gradient of 1, think about it. The line AB is going to be the diameter of the circle. How do we know that? Think about it. This is a tangent. This is a tangent. Tangent is perpendicular to the radius. Tangent is perpendicular to the radius. So if I were to draw a radius at the point B, it is going to pass through the center. If I were to draw a perpendicular line here to the tangent at this point B, it is going to pass through the center of the circle. And similarly, if I were to make a line perpendicular to the other tangent at the point A, that's also going to pass through the center. So the line AB is a straight line like this that passes through the center of the circle. It passes through the center of the circle. And AB is supposed to be the diameter of the circle. Okay? So what that means is we can write down the gradient of AB. Why? Because AB is perpendicular to the tangents. What's the gradient of AB? We can say gradient of AB is negative reciprocal of the gradients of the tangents. What's negative reciprocal of 1? Minus 1 over 1. That's minus 1. So we have the gradient. Okay, so that's one thing that we were looking for. Now the problem is we do not have a point given. Now, since it passes through the center, we know the equation of the circle. What's the center of the circle? Can we figure out the center of the circle from this equation? We can. Compare it with the standard form. X minus a whole squared plus y minus b whole squared equals r squared. What's the center? The center's coordinates are going to be 4 and minus 1. You just flip these signs. Minus 4 becomes 4, plus 1 becomes minus 1. These are the coordinates of the center of the circle. Okay? So the point O has these coordinates, 4 and minus 1, and the point O lies on the line AB. We have both the things that we needed. We've got the gradient, we've got a point. We can write down the equation now using y minus y1 equals m into x minus x1. What does that give us? Y minus minus 1, that becomes y plus 1 equals m, which is minus 1 into x minus 4. Now we could simplify this. They want our answer to be in this form, y equals mx plus c. So it's necessary for you to convert it to that form. You need to make y the subject. So it becomes y equals minus x plus 4 minus 1. And you get y equals minus x plus 3 from that. That's the equation of the line AB. That's the first part. That's what we were looking for in the first part of this question. Okay, now let's look at the second part. Now it says, find the coordinates of A, giving each coordinate in surd form. Now remember what surd forms are? Surd form is basically square root form. Square root, cube root, fourth root. So basically root form, that's what is known as surd. Now all that means is you don't have to use decimals in your answers. Everything should be left in exact form, and you would automatically get your answer in surd form. Okay, so you don't have to do anything special for that. It will automatically turn out to be in that form. Now, how do you find the coordinates of the point A? Let's think about that. This is the point A. We need the coordinates of this point. Now, one thing is that this point A lies on the circle. So whatever the coordinates are, let's call the coordinates x and y. We have one relation between the x and y coordinates already, and that's the equation of the circle. Since the point A lies on the circle, it has to satisfy the equation of the circle. Okay, so this is one equation that we have already between x and y, one relation between x and y. Okay, so x, y have to satisfy this equation. Okay, let me write that down. The equation that we have, x minus 4 whole squared plus y plus 1 whole squared, that equals 40. That's one thing that we've got. Now we need some other equation in terms of x and y. Okay, some other equation that connects x and y at the point A. Do we have any other equation in x and y? Can you think of one? Is there a way to write down another equation that connects x and y? Yes? No?
Length of OA.
Length of OA? But that's not specific to A, because
equation of line AB.
every single point on the circumference that has the same length. This is also the same. This length is also the same. This is also the same. So basically, the equation of the circle is already capturing that. That's where the equation of the circle comes from in the first place, using the lengths of the points on the circumference. So if you were to try doing that, you would actually end up with the same equation. So that is not going to help. We need a different equation. So using length of OA, you would get this equation back. That's not what we need. We need some other equation. Yes?
Equation of tangent.
Equation of the line AB.
Equation of the line AB. The point A lies on the line AB as well, right? So we could just think of it as think of point A as the point of intersection of these two graphs. One graph is the circle, and the other graph is this line. A and B, both of them are basically points of intersection of these two graphs, we can just solve these two equations simultaneously. That's all that we've got to do. Now we would get both A and B, but they're looking for A. So whichever one has the smaller X coordinate, we could say that's the point A. Okay. So basically we just have to solve this equation simultaneously with the equation that they've made us find in the first part. That's the equation of the line AB. Okay. If they had not made you find the equation of line AB, another idea could be that you could say gradient of OA. I think somebody said that as well. Gradient of OA, that also equals -1. We know that. So we could put the gradient of OA equal to -1. That would have given us another equation. And that would have actually been similar to this as well. But for now, since we are given the equation of the line AB and the equation of the line, equation of the circle, we can just solve them simultaneously, and that is going to give us the coordinates of the point A. Now, how do we solve these two simultaneously? We have y equals -x plus 3 here. We've got another equation here. We can put this in the first equation, put y equals -x plus 3 in the first equation, and that gives you x minus 4 whole squared plus minus x plus 3 plus 1 whole squared equals 40. And now you could simplify this and see what that gives you. X minus 4 whole squared plus minus x plus 4 whole squared equals 40. Now, these two are actually the same. If you think about it, x minus 4 whole squared, 4 minus x whole squared, they are both the same, basically. So if you are able to figure that out, you can actually make this process a lot simpler by just doing this. 2 into x minus 4 whole square equals 40. And just take it from there. X minus 4 whole squared equals 20. Take square root with plus minus and find the values of x. If you're not able to figure that out, the other possibility would just be to expand both of them. Let's expand them. You would get x squared minus 8x plus 16. And then you have minus x plus 4 whole squared. Now, be very careful with the signs that you're using. If you use a plus b whole squared, if you use that identity, a is going to be minus x. The whole thing minus x is going to be a in that case. So let's use a plus b whole squared equal to a squared plus 2ab plus b squared. Let's use that. If we use that, what's minus x whole squared? You can actually write it like this: minus x whole squared plus 2 into minus x into 4 plus 4 whole squared. It's very common to make sign errors in this case, so you have to be very careful. If you're confused, an easy way to do this is think of it like this: minus x plus 4 into minus x plus 4. Just evaluate this and you're less likely to make errors, the plus minus errors, if you do that. Okay, so if you're confused about how to use this identity here, just multiply it separately like that: minus x plus 4 into minus x plus 4, and that will work. Okay, on the other side, you've got 40. Now, let's simplify this. This gives us x squared minus 8x plus 16 plus x squared minus 8x plus 16 minus 40 equals 0. Now, let's try to simplify this. 16, no, it doesn't get cancelled. Minus 8x, x squared, 16. Okay, nothing is getting cancelled. So what do we get from this? We get 2x squared minus 16x, right? And you have 32 minus 40, that's minus 8 equals 0. Please check out for careless errors. I hope there are none. X squared minus 8x minus 4 equals 0. And now you need to solve this quadratic equation. How do we solve this quadratic equation? Can we factorize this? Well, we can't. We have to use quadratic formula. X equals minus b, so that's minus into minus 8 plus minus square root of minus 8 whole squared minus 4 into 1 into minus 4 whole divided by 2 times a. Now, it's necessary for you to show this working. Do not write down the answer directly. Whenever they ask you for exact answers, it's necessary to show every single step in your working. So if you're doing it like this, you would have to show that you're inputting values in the quadratic formula, and then what you get from that is 8 plus minus square root of, inside this, 64 plus 16. What's that? That's 80, right? So plus minus square root of 60 divided by 2. Now put square root of 60 in your calculator and see if that simplifies it in any way. Square root of 60. Yeah, so it becomes 2 under root 15. And then you take 2 common from the numerator and cancel it out to get 4 plus minus square root of 15. This is the x coordinate that you're getting. These are the x coordinates that you're getting for A and B. And I think it does not look correct because it's 4 plus under root 15, 4 minus under root 15. For A, it's supposed to be a negative x coordinate, right? So let me just check for errors. Now, for this reason,
It's under root
yeah,
80. Yeah, x
it's under
equals 8 plus minus 80.
Oh, yeah,
Root
I'm
80.
sorry. So I actually said 80, but then wrote 60. I'm sorry. Under root 80, that's 4 under root 5. Sorry. So this is 4 under root 5. Okay, so now this is also something that you can actually learn from. So I got these answers. 4 plus square root of 15 with my previous working, and 4 minus square root of 15. And now how did I realize that there's something wrong here? Both of these answers are positive. The first is obviously positive. Square root of 15 is less than 4. So that's also positive. And we know from the diagram, the x coordinate of A cannot be positive. That means there's something wrong here. All right. So you should be doing this sanity check when you're doing your working as well. Look at the diagram that's given and see if the answers that you're getting, if they make sense as well according to that diagram or not. Okay, so that's how you can spot errors like this. So here what I did was, instead of 60, I wrote instead of 80, I wrote 60 by mistake there. So under root 80, that basically simplifies to 4 under root 5. And then 8 over 2 is 4, and 4 over 2 is 2. So it's 4 plus minus 2 under root 5. That gives us 2x coordinates, 4 plus 2 under root 5 or 4 minus 2 under root 5. These are the 2x coordinates that we're getting. Now this is, this is negative now. These are 2x coordinates. Now what were we looking for? We were looking for the coordinates of the point A. A is the one that has a negative x coordinate. So we should be using this one, the one that has a negative x coordinate. This is the point A. We also need to find the y coordinate now. We've got the x coordinate. How do you find the corresponding y coordinate? You can put that in this linear equation. Y equals minus x plus 3. To get the corresponding y coordinate, y equals minus x plus 3. And that gives you y equals minus, put this whole thing in bracket. Be careful about that. X is 4 minus 2 under root 5. Put that whole thing inside brackets like this. And now you simplify this. Y turns out to be minus 4 plus 2 under root 5 plus 3. And the y coordinate is 2 under root 5 minus 1. This is the y coordinate of A. Now you can write both the coordinates together. You can say the coordinates of A therefore are 4 minus 2 under root 5 and 2 under root 5 minus 1. And that's your final result. This is the answer in third form. Okay. This is the point A that we were looking for. Okay, now let's look at the last part of this question. It says, find the equation of the tangent at A, giving the answer in the form y equals mx plus c, where c is in third form. So now we need to write down the equation of this tangent. What do we need to write down the equation of a straight line, a point, and a gradient? Well, we actually have everything that we need. We have the gradient of this line as well, and the point as well. We can write down the equation quite easily now. We just have to convert that to this form y equals mx plus c. Now let's do that. Part C, point A is already known. We know that the gradient of the tangent is 1. Let me just confirm if it's as straightforward as that, right? That's what they're asking for, tangent at A. Yeah, so that's all that they're asking for. Gradient is 1. Now, if you just put values in that standard form, y minus y1 equals m into x minus x1. And that will give you, now be careful with the signs. Y1 is this whole thing, put that inside brackets. Y minus 2 under root 5 minus 1, that equals m, which is 1 into x minus 4 minus 2 under root 5. And now let's simplify this. This gives us y minus 2 under root 5 plus 1 equals x minus 4 plus 2 under root 5. That becomes x minus 4 plus 2 under root 5 plus 2 under root 5 minus 1. And the final answer turns out to be x plus 4 under root 5 minus 5. You wanted C to be in third form. That's exactly how we have found here now. C is this whole thing, 4 under root 5 minus 1. And that's the equation of the tangent that we were looking for. Y equals x plus 4 under root 5 minus 5. And that's the final answer. Okay. Any questions on this? Any problems? Make sense? Now, just a reminder for those of you on YouTube, I have my past paper sessions going on right now as well. We started them on Saturday, and we have done a couple of papers already. Now, today we're going to be doing November 2023 papers, paper 1.1 and paper 1.3. Difficult questions from those papers, but that's in a closed group. If you want to register for that, you can have a look at the registration link in the chat box on the right side in the live chat, and also in the description below. If you want to register for that, you can find all the details there in the description, in that registration form. And if you have any questions, you can post those questions on my Instagram or on my WhatsApp, or send me a message on WhatsApp, and I'll respond to you. Okay. So I'll hopefully see some of you there as well. The past paper sessions have already started. So in case you want to join, you can do that soon, because we only have a few weeks left now before exams, and we've already started doing those papers now. All right, so that's it for today. Those of you who are here, let me know if there are any other questions. Abdullah, Hazem, Nehima, Rajal, and others. Any problems, anyone?
No, sir.
No, sir.
No, sir.
Okay, so that completes equation of circle for us. We've done enough practice on this as well. You should do more, of course. Make sure that you're done with all the assigned questions from the worksheet, and do more practice from recent papers as well. And tomorrow we are going to be starting practice questions on arithmetic and geometric progressions. We're done with all the concepts of APGP as well, right? But we haven't done enough practice. So the next couple of classes, we'll have at least two more classes in which we will be doing practice questions on AP and GP. All right, but that's for the next class. That's it for today. I'll see you again in the next session. Allah Hafiz.
Allah Hafiz, sir.